Hi everyone. In this video, I'll be discussing about the transformer architecture. So I think you know that transformer is the core architecture behind all the large language model. So if you want to understand the large language model, how it works, actually how it takes the entire input from the user, how it let's say remember the previous context. So first of all, you have to understand this particular architecture, because in this architecture there are some very amazing concept actually has been used. So with respect to that particular concept, this architecture can work with actually very complex kinds of data, okay, and it will give you like good performance. So if you search over Google the transformer architecture, so you'll get this particular paper link called attention is all you need. So this is the official paper from the Google site. So Google has published this particular architecture. So Google has published this particular paper and you can see the author name. Okay, so these are the author, actually they're from Google brain team. Actually they developed this particular architecture. So if you have time, you can go through the entire paper. Guys, you can see this is the paper introduction, background, okay, and this is the architecture of the transformer. Now at the very first time, if you're seeing this particular architecture, I know that it would be a little bit hard to understand, okay, whatever let's say things they have mentioned here. So I'll try to break down the architecture, then I'll try to discuss. I think then after that this part would be more clear. Okay, so guys, what I'm going to do, I'm going to break this architecture, okay, and I will try to discuss each and everything. For this I'm going to refer one amazing blog from JLMR. So if you search like JLMR actually transformer architecture, so you'll get this particular blog. Okay, the first website, this is the blog. So he has actually created this particular blog in an amazing way. He has used actually lots of visualization to explain the transformer architecture. So the entire video I want to dedicate to JLMR because of him actually I was also able to understand this particular transformer mechanism. Got it? So guys, you can see this is the blog. So first of all, he has shown like the high level overlook of the transformer. Let's say initially you can consider transformer is the black box. Okay, this is the transformer. So here let's say you are giving one input and you are getting an output. So the example he has shown with respect to the language translation. So he is passing actually French language and he is getting a English output. Okay, as in so here he is passing actually French input and he is getting English output. Got it? So initially let's say this is the transformer. So if you give any input, so it will return you some kinds of output. Now if I show you inside the transformer what we have. Okay, inside the transformer what we have, you can see inside the transformer we have two kinds of layer. One is the encoder layer, another is the decoder layer. So those who have already studied about basics of NLP, I think you know that inside NLP, inside RNN actually we have some networks like LSTM, GRU, okay, encoder, decoder. So these are the architecture were available. So this is the same encoder and decoder architecture. Now what we'll do, we'll just try to see what we have inside encoder and what we have inside decoder. So guys, you can see we usually pass the input to the encoder layer and decoder layer gives us the output. So here we are passing the French input to the encoder layer and it is going to the decoder layer, okay, after doing some pre-processing, and decoder layer is translating this particular French to English and it is giving you the output. Okay, that means inside encoder and decoder some mechanisms are happening. We'll try to see what are the mechanisms are happening. Okay, everything we'll try to discuss. Now see guys, I will suggest you after this particular video, just go through this particular blog and just try to read these are the, let's say, text, okay, whatever he has written. See, whatever things I'm going to explain through the entire video, so the same thing you will be getting, okay, with respect to the text. Got it? So first of all, try to watch this particular video, then go through this particular blog and try to read everything whatever he has written, then your understanding would be more clear. Got it? Now you can see guys, in the encoder layer, okay, in the encoder layer we have, okay, we have 8 encoder layer. We have 8 encoder layer. It's not like that they're only using one encoder layer. No, they are using, okay, 8 encoder layer. You can see 1 2 3 4 5 6 1 2 3 4 5 6, sorry, 6 encoder layer. Okay, not 8. This was my mistake. 6 encoder layer actually they're using in one encoder, okay, layer. Now inside decoder again you have 1 2 3 4 5 6 decoder layer. Got it? That means whatever input you are passing, it will go through 6 encoder layer then some pre-processing would be happening, some processing would be happening, then it will return the output to the decoder. Then again the output will go through the 6 decoder layer and you will be getting the output. Okay, I hope it is clear. Now you can see guys, in the encoder layer we have two kinds of layer. One is the self attention and the feed forward network. Okay, I'll be talking about the self attention. What is self attention exactly? And I think you already know what is feed forward forward neural network. Okay, feed forward neural network is nothing but it's a artificial neural network, dense layer. Okay, I think you know that all the architecture has this particular feed forward neural network, okay, at the last layer. So that's why they're also using that particular network here. Now you can see this is the overview. So in the encoder layer we have self attention and feed forward, and in the decoder we have self attention, encoded decoder attention, and feed forward. Okay, now what is encoder and decoder attentions? That means after explaining this particular self attention, okay, I'll talk about this part, but you can consider they're combining encoder and decoder attention layer together and they're using inside the decoder. Okay, this is another layer actually they're using inside decoder. That's it. Now let's try to see one example. So let's say this is our input x1, x2, and x3. So here we are passing a French sentence, you can see. So this is the French sentence, and here is my architecture. So this is the French sentence actually I'm passing. First of all, it will go through the encoder layer, and encoder layer has how many encoder layer? And you know that 8 encoder layer. 6 encoder layer. And in one encoder layer, what we have? Okay, we have two kinds of layers, self attention and feed forward. So first of all, it will go to the self attention, and self attention will return some output like z1, z2, and z3. Okay, then it will go to the feed forward, and feed forward will give you some output. Now how this z1 and z2, z3 we are getting, we'll try to understand. Now you can see guys, here is the let's say demo. So ZLMR, what he did actually, instead of taking 3, let's say word, he has taken 2 words just to explain the things easily. So now let's say this is our words, thinking, and machines. We are passing to the self attention, and self attention is returning one output z1 and z2, and we are passing it to the feed forward. Feed forward is giving me one output, let's say r1 and r2, and this particular output we are passing to the another encoder layer. That means we have 6 encoder layer, right? So it will go through the 6 encoder layer like that. Okay, dot 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 like that. So now you can see self attention at a high level, how it works. So let's say this is one sentence I have. The animal didn't cross the street because it was too tired. Okay, it was too tired. Now here you can see it was too tired. Now what this it represents? So as a human, I think you understand it represents the animal. Yes or no? But what about machine? How machine will identify this it is the same thing as the animal? Okay, for this we have to apply the self attention. Okay, now you can see this is the like your entire sentence. The animal didn't cross the street, it was too tired. Now to represent it, actually it is giving the attention to this particular word. You can see the animal didn't. Okay, so these are the word actually it is getting attention. Okay, to represent the it. Now how it is getting the attention? Okay, we'll try to understand how it is giving this particular word as an attention. Okay, so we'll try to understand this particular thing. Now you can see some of the word is getting very less attention. You can see because of this line is like very what I can say, it's not visible properly. Okay, now you can see self attention is detail. So how this self attention happens, we have actually so many words, but how it will give the more attention to the specific word, we'll try to understand from this particular example. So let's say this is our word thinking and machine. So first of all, what we have to do guys, I think remember, first of all we usually generate the embeddings, like we convert this text to the embedding model. Okay, sorry, embedding representation. Okay, embedding numbers, that means the vector numbers. Then what we do guys, we initialize some weights. I think you know that in neural network we initialize the weights, right? So in this case actually we initialize 3 kinds of weights: w, wq, wk, and wv. Let's say this is our weights. Okay, now to represent this queries, keys, and values, what needs to be done? So you will be multiplying this x1 with w1. Okay, x1 with x1 with wq. Okay, x1 with wq, then you will be getting q1. Okay, then if you multiply x2 with wq, you will be getting q2. So similar wise, if you multiply x1 with wk, you will be getting k1, x2. So here see the calculation is happening like that. So let me take the pen. So x1 is getting multiplied with wq and you are getting q1. Okay, then x2 is getting multiplied with wq and you are getting q2. Then again x1 is getting multiplied with wk, so you are getting k1, and x2 is getting multiplied with wk, you are getting k2. Then x1 will multiply with wv, you will be getting v1, and x2 will multiply with wv, you will be getting v2. Okay, so that's how you are getting query, keys and value. Okay, these three particular vector you will be getting and will be naming as query, keys and values. Okay, I hope you got it. Now let me just clear everything. Now we can see, guys, we are the query, keys and values, okay, vector. Now here you can see this is the another example. So let's say this is our word. We did the embedding generation, then we got q1 k1 and v1, that means query, keys and values. Okay, and how, I think I already showed you. Now you have to like get this code. Okay, how to get this code? You have to multiply this q1 with k1. Okay, q1 with k1. So if you multiply, you will be getting this particular number. Then again, for the machines, what you have to do, you have to multiply q1 with k2 and you'll be getting the number. Now you can see I mean, which word is having more number? So definitely thinking is having more number here. Okay, 112. So thinking is having more number than the machines. Machine is having 96 and thinking is having 112. Okay, now here will be like generating some, let's say I mean percentage number. For this, some more calculation needs to be done. You can see again the same thing is happening. We are getting the score. Now we have to divide this particular score by 8. Okay, then after that you will be getting the number. Then you have to apply the softmax activation function. I think you know what is softmax activation function. It will give you the probability number. Okay, so in this case we are getting 88% probability of the thinking, and machines we are getting only 12% probability. Now that means your model is giving more attention to the thinking words. Okay, your model is giving more attention to the thinking words. That means thinking words is important, okay, in this particular sentence. Okay, so that's how actually this particular self attention works. It will give you the attention like that. So these are the calculation it will be doing, and it will give the calculation like that. Okay, now I think you are getting. Now one thing, so after doing the softmax, you have to multiply with the value. So this particular value you have to multiply, then we'll be getting the z1 and z2. Now I think you understood so why we are getting the z1 z2 here. Okay, so after going through the self attention, z1 z2 and so on. Okay, so now I think this particular I think part is clear. Okay, what is z1 z2 and so on. So yes, so the same calculation I showed you, so he has also shown with respect to the graph, with respect to the matrix. So first of all you have the input, then you are generating the keys and queries and these particular values, okay, by multiplying with wq, wk and wp. Then after that you are applying the softmax activation function. Okay, then you are getting the z1 z number. Then see, this is for the single head attention. Okay, only single head attention. And what is the problem with single head attention? See, some of the word is getting ignored here. Okay, you can see this line is not visible. To represent it, actually these are the word is also required. Now to prevent this particular issue, they have introduced something called multi-head attention. Okay, multi-head attention. So instead of using single head attention, see the calculation we have done, it is only happening with a single head attention. Now what is the main benefit in the multi-head attention? They are using more attention layer. Okay, they're using more attention layer. How many attention layer? They're using 8 attention layer. Okay, you can see calculating attention separately in 8 different attention heads. That means the same attention, whatever calculation I showed you so far, they're using the same attention mechanism, but they're doing in 8 attention layer. Okay, 8 multi-head attention layer. Okay, that's why they're calling as a multi-heads. Okay, multi-head attention. The same calculation, you can see the same calculation, and after that we are getting z1, z2, z3 and so on. Then we are doing the summation operation. Okay, then we are only getting 1z. So see, this is the entire calculation. Okay, with the multi-head attention. Now after doing the multi-head attention, this is the results, guys. Okay, you can see now those word actually was getting ignored. Now it is also trying to capture. Okay, now you can see amazingly it is trying to capture. So this is the main benefit to use the multi-head attention. Okay, now transformer, whatever let's say large language model will be using, all the large language model use the multi-head attention mechanism in the backend. So these are some more visualization. You can see so this is the visualization. Now now we'll try to understand the positional encoding concept, like how this positional encoding works. So what is positional encoding exactly? So see, here you initialize one vector. Okay, this particular vector you initialize like t1, t2 and t3. So what happens actually, this positional encoding, see, it will try to capture the semantic meaning, okay, of your sentence. Let's say you have passed one sentence, they switch, okay, edudent. So after they switch is coming, okay, after switch edudent is coming. How your model is trying to understand this thing? Because of the positional encoding, because this is the vector, this is another vector, this is another vector. Now what you will you have to do, let's say if you subtract this vector with respect to this particular vector and this vector with respect to this particular vector, which will have very less, let's say, distance, definitely this will have the less distance, okay, that time I can consider this switch is nearest to the JE, okay, then this edudent, okay. So that's how actually they are getting the semantic information, semantic meaning, okay. After this JE switch is coming, after switch this particular edudent is coming, okay. That's why they're trying to capture the semantic information with respect to the positional encoding. So that's why it is also super important, because you will be passing actually very big prompt here, big, let's say, input, and to capture the semantic information, this is the way actually they're using. Got it. Now let's try to see the next thing. So see guys, this is the positional encoding concept. It's a vector only at the end, and if you just do the distance calculation with respect to all the vector, you'll see that this particular word will come nearest to this particular vector. Now these are some actually visualization graph he has shown. Now there is another concept inside this transformer architecture called residual block, okay. So those who have started computer vision like CNN architecture, I think you know that there is an architecture called ResNet 50, okay. So ResNet 50 has also this residual networks. What is residual networks actually? So it has actually one skip layer. So why we use the skip layer? Because sometimes, let's see, if you have very less complex data, so by going through some actually layer, you'll be able to get the higher accuracy. That time you don't need to go through all the layer. That time actually what it will do, it will skip the, let's say, layer. Let's say this self attention is not required. Directly it will pass to the normalization. I think you know what is normalization. It will normalize the data, okay. Then after normalization, let's say it will again jump to the another normalization instead of feed forward neural network, okay. So that's how it will skip automatically based on the performance of the, let's say, loss function or whatever actually you are using internally. So the same thing, whatever you have learned in the ResNet architecture, the same concept also using here, okay. If you are not understanding, if you're not sure about the let's say ResNet architecture, you can go through and you can see that, okay, how ResNet architecture works. Now here you can see guys, this is the entire architecture overview. Now this is the final one. So we are passing the words and it is going to the encoder. Inside encoder we have self attention, some normalization layer they have also added, and feed forward again some normalization they have added, okay. Then again it will go to the next one, okay. Next one will pass to the decoder, okay. That means 6 encoder it will be passing, then it will go to the decoder layer. And so decoder actually, again you can see I have self attention, normalization, and encoder and decoder attention. That means encoder and decoder they have combined and they have created one architecture and they are using inside this particular decoder, okay. And this particular output will go to the decoder, okay. Decoder second layer of decoder. Then after that they are applying the linear, okay. Then they are applying the softmax and we are getting the output, okay. Now you can see guys, these are some visualization. You are passing the input, it will go to the decoder, okay, and some processing is happening, okay, and you are getting the output. Hi, got it. Now let me show you the entire visualization, how these things working. You can see. So if you have time, just try to open the this blog and you will be able to understand, okay, how things are working. See, it will coming here, and again the output we are getting here, it is going as an input to the decoder, okay, and it is predicting this one. See, so this is the French and this is the English translation of that. And whenever you are getting end of the sentence, that means your sentence is done, okay. Your execution would be terminated that time, okay. That's how the entire architecture works, okay. Now guys, see, these are the things are not required. Yeah, so this is the actually mechanism of our transformer architecture. That's how actually self attention works. Now going forward, whatever LLM you will be learning, okay, all the LLM are using this particular transformer architecture in the backend. Now if I open this particular architecture, now if I show you, you will see here, and now I think you will be able to understand what is input embeddings, what is positional encoding, okay, what is multi-head attention, what is normalization, what is feed forward, again what is normalization, and this is called actually our encoder layer, okay. Then we are passing the output to the decoder layer, okay. That means in the decoder we have mask multi-head attention, that means encoder and decoder, okay, both combined architecture. Then normalization, then again a multi-head attention, then normalization, feed forward, normalization, linear and softmax, and we're getting the output. That means this is the entire decoder layer. And again we're using positional encoding, okay, just to get the semantic information. Okay, now this particular architecture, this JLMR actually break down, okay, in this particular block, and he has explained each and everything with respect to the visualization. Okay, so this is one of the amazing blog, guys. Again, I'll try to suggest you just go through this blog and try to read everything, whatever things I have explained so far, everything he has written, okay, with respect to the text. Now you can also go through the paper also. In the paper they have also, let's say, mentioned the mathematical equation and all. If you're interested, you can also go through this particular paper. So yes, guys, this is all from this particular video. So here we have explained about the transformer intuition. I hope you have liked it. Thank you so much. Hi guys. In this video, I'll be talking about some component of the large language model. So if you have seen my previous video, so there I was discussing about a transformer intuition, and I showed you like different transformer component, how transformer works, what is self, let's say, attention mechanism, everything I explained. Okay, and I also told you transformer is the core architecture behind all the large language model. Okay, nowadays we are using. So the same, let's say, component you'll be also getting in the large language model. So let me write down some of the component. So see, in the large language model, you have LLM. Okay, you have something called tokenization layer, tokenization layer. Then you also have something called embedding layer. Okay, embedding layer. Okay, so what happens in the tokenization layer? We just try to create the tokens of the sentence, whatever sentence we have. Then with respect to the embedding layer, we try to generate the vector embedding. Okay, then we have something called transformer blocks. Transformer blocks. So whatever things we have learned in the transformer, the same thing would be available here. Okay, that means the core transformer. Okay, whatever we have learned, that means we have multi-head attention. Okay, we have normalization layer, feed forward neural network. Okay, residual connections. Okay, then stacking the transformers. So these are the things that are available inside that. Then additionally, he will be also getting something called some additional components are also there inside LLM. Like we have something called rotary, positional, embedding. Okay, we also call it as ROPE. Then we have KV, cache. Okay, so we use usually these particular things during inference. Okay, then we have layer, scale, deep norm. Okay, then RMS norm, normalization. Then we have LoRa, adapter. Okay, LoRa adapters, and PFT module. PEFT module. So parameter efficient fine tuning module, we call it. Then we have mixer of experts, MOE. Okay, so these are some additional component you will be getting inside LLM. Because LLM training is a little bit different than our previous let's say language model training. So here we use different things like supervised fine-tuning approach will be we usually use here. So that's why these are the, let's say, component is also important there. So yes guys, these are the things are available inside large language model. So the main architecture would be your transformer blocks. Okay, with the help of that it understand all the context and it gives the attention, everything I think I already showed you in that particular video. So yes, this is all, and I hope you understand. Thank you guys. Hi guys, in this video we'll try to understand tokenization and embeddings. So first of all, let me discuss about tokenization. Tokenization. Okay. So we'll also try to do this thing as a practical so that your understanding would be more clear. So what is tokenization exactly? So let's say here I have a sentence. Let's say my name is Bappi. Okay, so this is my, let's say, sentence. Now if I perform tokenization, see, tokenization is two types. One is word level tokenization. Okay, another one is sentence level tokenization. Okay, so first of all, let's try to see word level tokenization. Then I will also show you sentence level tokenization. See, word level tokenization, what happens? Let's say word token. It will create a list, and let's say this is our sentence. So it will create a token like that. First of all, my will come. So my is an individual word. Then name will come. Okay, then comma is will come. Okay, then comma Bappi will come. Now how many token we got? 1, 2, 3, 4. 4 tokens we got. Okay. Now let's say here another sentence you have. I am a good boy. Okay, good boy. So let's say this is another sentence. Now if you apply word level tokenization, what will happen? Okay, it will create another list, and inside that it will add everything. Let's say I am, okay, then a good boy. Okay, so this is what your word level tokenization. Now let's try to see the sentence level tokenization. So sentence token. Okay, how sentence token works? See, it will be tokenizing with respect to the sentence. So first of all, first sentence will come, my name. Okay, name is Bappi. So this is going to be one token, then comma, then second sentence, I am a good boy. Good boy. Okay, then bracket would be closed. So this is called sentence level tokenization. Okay, now there are some more tokenization concepts are available, like byte pair tokenizations. Okay, these are the things also can be used. Now let's try to see the tokenization in a practical way, how this tokenization can be done. Then I'll be discussing about the embeddings. Okay, like embeddings means how we can convert this text to the numerical representation, because we know that our model can't take the raw text input, so we have to convert to the vectors, convert to the numbers, and for this there are various kinds of techniques are available. Okay, so I'll show you some, let's say, easy technique, because whenever you are working with the large language model, you will be using some advanced technique like transformer based embedding technique you will be using. So there are some embedding models are available. With the help of that, we'll be creating the embeddings. Okay, so whenever I'll try to show you the project implementation, that time I'll tell you, but as of now, just to show you demo how we can convert this text to numbers, I'll be talking about some, let's say, very common embedding technique, okay, we can use. So for this, I'm going to open up my Google Colab. So here, let's create a new notebook. Okay, so here I'm going to name it as tokenization and embeddings. So here what I will do, I'll connect a notebook. So first of all, I'm going to show you the tokenization. So for this, we need the NLTK library. So first of all, we have to import the NLTK. So from NLTK dot first of all, I will try to import the NLTK. Okay, so import NLTK. Okay, then I need the tokenization functionality from the NLTK. For this, we have to import from NLTK dot tokenize. Okay, I think tokenize import. I'll import two kinds of tokenization. One is word level tokenization and sentence level tokenization. Both will try to show you. Okay, and now let's import it. It's working. Now let's say first of all I will mention some sentence. Let's say this is my sentence. So here I'm going to write, let's say my name is Bappi. Okay, so first of all I will try to apply the word level tokenization. To apply the word level tokenization, you have to use this function from the NLTK, word tokenizer. Okay, now inside that you have to pass the sentence, and this will give you your word underscore token. Now I'm going to print that word token. Now if I execute, it is giving me one error. It is telling resources punc tab not found. Please use the NLTK downloaded to obtain the resources. Okay, see, if you are using NLTK library, so you have to use some resources. Okay, you have to download some resources. So for this is the code. I'll try to copy, and what I will do here, just let me mention it. Now this punc tab would be downloaded. Now let's execute it again. Now see guys, it is working fine. Now this is what your word level tokenization. Okay, I hope you got it. Okay, so that's how individual word will come inside a token. Now we'll try to see the sentence level tokenization. Okay, so what I will do, maybe I can copy the same sentence and I will add some more text here. Let's say here I will add I am a good boy. Now this thing I will pass to the sentence level tokenization. Okay, so let's pass to the sentence level tokenization, and this will give my sent token. Going to print it in the console. Now guys, you can see my name is Bappi and I'm a good boy. Okay, I hope it is clear. So see why we have to use the tokenization, because if I want to generate the embeddings, that means the vector embeddings, first of all I have to convert my entire sentence to individual tokens, and this particular individual tokens would be converted to the embeddings. This is the process, okay, to convert to the embedding. That's why at the very first time we have to do the tokenization. Got it? That's why it's super important. Now I'll show you how we can do the embedding generation. So, okay, I think you know what is embedding generation. Embedding means we have to convert this text, okay, somehow to the numerical representation, somehow to the vector representations. Okay, this is what we'll be learning. Now there are some embedding techniques. See, OpenAI also has some embedding technique. Let me show you. OpenAI embeddings model. So with the help of these are the model, you can generate the vector embeddings. Even some open source embedding model are also available. So embedding model you can see. So they're using text embedding 3 small model, and they are giving the input text, and this is the vector embedding they are getting. Okay, so that's how we have different models are available. Then some Hugging Face embedding model are also available. Hugging Face embedding models. Different models are available. See, these are the models you can use for the embedding generation. Got it. Now I'll show you some, let's say, common embedding generation model, like technique, like we'll be using some. Now I'll show you some very common, let's say, embedding generation technique, like bag of word is there, TF-IDF is there. Okay, so these are the things you can also use. But see, in an exact implementation in the large language model, we are not going to use it. But just to show you, okay, how things are working, I'll show this part as a practical. So for this, what I will do, first of all, let me show you the bag of word technique. So here, let me just comment. embeddings. So I'll show you the bag of work. So let's create a data first of all. So import pandas as PD. Okay. Then I also need numpy. So import numpy as np. Then I will create a data. So here I already prepared a data. So let's say this is our data. I'm converting to the data frame. So this side you have the text like people watch this with Buppy, this with Buppy, watch this with Buppy. Okay. So that's how I have some, let's say, comments. Okay. Now with respect to the comments, I have some output. As of now, you can consider as a label. Okay, but I don't need the label. I only need the text because I want to show you how we can convert these other text to the vector representation. Okay, just to create the data, I just mentioned some of the output. Let's say output category, dummy output category. Okay, now to apply the bag of word from the sklearn, we have to import one function. So from sklearn dot feature extraction. Okay, it is available in the feature extraction dot text. I have to import counter vectorizer. Feature extractions. So yeah, so counter vectorizer, I think. Feature extraction counter vectorizer. So let me import. Okay, so it is telling no module name. What is the issue, guys? Let me check. Okay, it should be text, not text. Okay, text. I have written text, that's why it's not working. Now let me import. See, it's working. Now let's create an object of counter vectorizer. I'm going to name it as CV is equal to counter vectorizer. Now inside that I have to give the data. Okay, inside that I have to give the data. So here how we'll be passing the data. So here I'll just write CV dot fit transform, and here I'm only going to pass my text data. Okay, and the beauty of this counter vector is it will automatically perform the tokenization. You don't need to manually do it. Okay, it will automatically perform the tokenization. Okay, word level tokenization, and it will apply the vectorization technique. Now let me show you. If I execute, so here you got the number. So if you want to see the number, you have to write bow to array. Okay, so it will give you the representation of the vector. That means these are the text has been converted to these are the vector right now. Okay, now I can pass this vector to the model. This is the technique. Now there is another technique you will be getting called TF-IDF. This is another frequently used in the machine learning. So let me show you TF-IDF demo. So the full form is term frequency inverse document frequency. Again, I'm going to create the same data. Now we'll be initializing the TF-IDF from the sklearn. So it is available in the sklearn TF-IDF vectorizer. Okay. Now again, you have to do the same thing. So you have to fit transform the data. So here, fit transform, we are giving the text. Again, it will perform the tokenization at the very first time, word level tokenization. Then it will perform the embedding generation. Okay. Now if I show you my array dot to array. Now these are the vector representation, and the beauty of this one, see previously you were getting zeros. Okay, and I think we know that zero is like unnecessary data. It will increase the computation. It's a dense vector actually we got, but here you can see it's a floating number. Okay, so that is the like main advantage to use the TF-IDF vectorizer. There's some more technique like what to vec is there. And now nowadays we inside LLM we will be using transformer based embedding model like I showed you. These are the embedding model. Okay, so this is like very powerful model. Even OpenAI also have some embedding model. So guys, now I will also show you some advanced, let's say embedding generation technique with the help of transformer model. So here, just let me write down advanced embedding technique with transformers. Okay, transformers. So for this, we'll be using Hugging Face actually platform, because I told you Hugging Face has lots of actually embedding model. Okay, you can use it for the embedding generation. So let me show you some demo. So here, first of all, we'll be installing the Hugging Face. Okay, and to install the Hugging Face, this is the command you have to execute: pip install transformer, and make sure you have selected your runtime to GPU. I'll be selecting the free GPU, T4 GPU. Now let's install it, because here we are using the transformers let's say model, and it needs actually a higher computational system. So for this we have selected the GPU. Okay, you can also do it on CPU, but it will take lots of time, that's why. Then after that, we'll try to import the transformer. Import transformers. Okay, it's working fine. Now from transformers, we'll be importing something called auto tokenizer. Okay, so see, if you're using transformer model, you have to use this library called auto tokenizer if you want to generate the embeddings. Okay, auto tokenizer. Now inside that, you have to specify the pre-trained model, the model you want to use for the embedding generation. So here, this is the code. So here you can see guys, auto tokenizer from pre-trained. So here I'll be using BART based uncased model. Okay, and this will be my tokenizer object. Now let's say here I have a sentence called I was so not happy with the Barbie movie. That's this particular sentence I want to generate the embeddings. Then what is the beauty of this transformers, let's say embedding, or let's say tokenizer? It will also perform the tokenization at the same time. Let me show you. So first of all, you have to apply the tokenization. So how to perform the tokenization? Like that, tokenizer.tokenize. Then you have to pass the text. Now if I print it, you will see that this is the token. And what is the token, guys? It has applied word level tokenization. I think I should already explain this part, right? Word level tokenization, your transformer model will apply. Now I have the individual word. Okay, so now we'll try to convert these tokens to the vector embeddings. So for this, this is the code you can see. So you can directly pass this text to the tokenizer. The tokenizer we have created is tokenizer object. Okay, tokenizer, I'm passing the text, and this will return me the encoded output. That means the embeddings. Now let me show you. So this is the output, guys. So you can see this is my vectors. Okay, this is the vectors, and you will be also getting some token type IDs and attention mask. Why attention mask? Because I already told you about the attention mechanism. There, it was giving the attention to the word. Here's one means it is giving the attention to all the words. Okay, all the words of this particular sentence. Okay, and how attention mechanism works, I think you already know, because these are the transformer based model. Okay, internally they're using. That's it. So this is the input I have to pass to the model. Now, if you want to decode, that means convert this vector to the text representation again, you can also decode it. So this is the code for that. Okay, decode. So to do the decode operation, you have to generate the input IDs. So how to generate the input IDs? So like that, you can generate the input IDs. Let me show you. So tokenizer, convert tokens to IDs. You have to give the token, this particular token. So it should have the this ID reference. Then it will be able to convert to the text again. Now this input IDs you have to pass here. Now it will give you the decoded output. That means the same sentence. I was not so happy with the Barbie movie. Got it? So that's how, guys, we use transformer model to perform the embedding operation. I hope it is clear. So yes, guys, this is all about our tokenization and embedding. I think you got to know. And that's how before passing any data to the model, we perform these are the steps. then we do the fine tuning or training, whatever you can say. So yes guys, this is all from my side. Thank you so much. Hi guys. To understand the attention mechanism, I'm going to refer the same blog written by JLMR, because he has explained this particular concept in a very easiest way with lots of visualization and all. So here I will try to understand this attention mechanism concept with one of the amazing architecture, I think you know that, called transformer architecture. And this is the paper of transformer. So this is the main architecture, and inside that they propose something called attention mechanism. Okay, attention mechanism. And they have some layer called multi-head attention. We'll also try to understand. So let's try to see this particular blog, and we'll try to let's explain the concept, okay, in the easiest manner. This is the blog. So first of all, he has shown like the high level overlook of the transformer. Let's say initially you can consider transformer is the black box. Okay, this is the transformer. So here let's see, you are giving one input and you are getting an output. So the example he has shown with respect to the language translation. So he is passing actually French language and he is getting a English output. Okay, as in so here he is passing actually French input and he is getting English output. Got it? So initially let's say this is the transformer. So if you give any input, so it will return you some kinds of output. Now if I show you inside the transformer what we have. Okay, inside the transformer what we have, you can see inside the transformer we have two kinds of layer. One is the encoder layer, another is the decoder layer. So those who have already studied about basics of NLP, I think you know that inside NLP, inside RNN actually we have some networks like LSTM, GRU, okay, encoder, decoder. So these are the architecture were available. So this is the same encoder and decoder architecture. Now what we'll do, we'll just try to see what we have inside encoder and what we have inside decoder. So guys, you can see we usually pass the input to the encoder layer and decoder layer gives us the output. So here we are passing the French input to the encoder layer and it is going to the decoder layer, okay, after doing some pre-processing, and decoder layer is translating this particular French to English and it is giving you the output. Okay, that means inside encoder and decoder some mechanisms are happening. We'll try to see what are the mechanisms are happening. Okay, everything we'll try to discuss. Now see guys, I will suggest you after this particular video, just go through this particular blog and just try to read these are the, let's say, text, okay, whatever he has written. See, whatever things I'm going to explain through the entire video, so the same thing you will be getting, okay, with respect to the text. Got it? So first of all, try to watch this particular video, then go through this particular blog and try to read everything whatever he has written, then your understanding would be more clear. Got it? Now you can see guys, in the encoder layer, okay, in the encoder layer we have, okay, we have 8 encoder layer. We have 8 encoder layer. It's not like that they're only using one encoder layer. No, they are using, okay, 8 encoder layer. You can see 1 2 3 4 5 6 1 2 3 4 5 6, sorry, 6 encoder layer. Okay, not 8. This was my mistake. 6 encoder layer actually they're using in one encoder, okay, layer. Now inside decoder again you have 1 2 3 4 5 6 decoder layer. Got it? That means whatever input you are passing, it will go through 6 encoder layer. Then some pre-processing would be happening, some processing would be happening. Then it will return the output to the decoder. Then again the output will go through the 6 decoder layer and you will be getting the output. Okay, I hope it is clear. Now you can see guys, in the encoder layer we have two kinds of layer. One is the self attention and the feed forward network. Okay, I'll be talking about the self attention. What is self attention exactly? And I think you already know what is feed forward forward neural network. Okay, feed forward neural network is nothing but it's a artificial neural network, dense layer. Okay, I think you know that all the architecture has this particular feed forward neural network, okay, at the last layer. So that's why they're also using that particular network here. Now you can see this is the overview. So in the encoder layer we have self attention and feed forward, and in the decoder we have self attention, encoded decoder attention and feed forward. Okay, now what is encoder and decoder attentions? That means after explaining this particular self attention, okay, I'll talk about this part, but you can consider they're combining encoder and decoder attention layer together and they're using inside the decoder. Okay, this is another layer actually they're using inside decoder. That's it. Now let's try to see one example. So let's say this is our input x1, x2 and x3. So here we are passing a French sentence, you can see. So this is the French sentence and here is my architecture. So this is the frame sentence actually I'm passing. First of all, it will go through the encoder layer, and encoder layer has how many encoder layer? I think you know that 8 encoder layer. Sorry, 6 encoder layer. And in one encoder layer, what we have? Okay, we have two kinds of layers, self attention and feed forward. So first of all, it will go to the self attention, and self attention will return some output like Z1, Z2 and Z3. Okay, then it will go to the feed forward, and feed forward will give you some output. Now, how this Z1 and Z2, Z3 we are getting, we'll try to understand. Now you can see, guys, here is the let's say demo. So ZLMR, what he did actually, instead of taking 3, let's say word, he has taken 2 words just to explain the things easily. So now let's say this is our words, thinking and machines. We are passing to the self attention, and self attention is returning one output, Z1 and Z2, and we are passing it to the feed forward. Feed forward is giving me one output, let's say R1 and R2, and this particular output we are passing to the another encoder layer. That means we have 6 encoder layer, right? So it will go through the 6 encoder layer like that. Okay, dot 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 like that. So now you can see self attention at a high level, how it works. So let's say this is one sentence I have. The animal didn't cross the street because it was too tired. Okay, it was too tired. Now here you can see it was too tired. Now what this it represents? So as a human, I think you understand it represents the animal. Yes or no? But what about machine? How machine will identify this it is the same thing as the animal. Okay, for this we have to apply the self attention. Okay, now you can see this is the like your entire sentence. The animal didn't cross the street, it was too tired. Now to represent it, actually it is giving the attention to this particular word. You can see the animal didn't. Okay, so these are the word actually it is getting attention. Okay, to represent the it. Now how it is getting the attention? Okay, we'll try to understand how it is giving this particular word as an attention. Okay, so we'll try to understand this particular thing. Now you can see some of the word is getting very less attention. You can see because of this line is like very what I can say, it's not visible properly. Okay, now you can see self attention is detail. So how this self attention happens, we have actually so many words, but how it will give the more attention to the specific word, we'll try to understand from this particular example. So let's say this is our word thinking and machine. So first of all, what we have to do, guys, I think remember, first of all, we usually generate the embeddings, like we convert this text to the embedding model. Okay, sorry, embedding representation. Okay, embedding numbers, that means the vector numbers. Then what we do, guys, we initialize some weights. I think you know that in neural network we initialize the weights, right? So in this case, actually we initialize 3 kinds of weights: W, WQ, WK and WV. Let's say this is our weights. Okay, now to represent this queries, keys and values, what needs to be done? So you will be multiplying this x1 with w1. Okay, x1 with x1 with wq. Okay, x1 with wq, then you will be getting q1. Okay, then if you multiply x2 with wq, you will be getting q2. So similar wise, if you multiply x1 with wk, you will be getting k1, x2. So here see the calculation is happening like that. So let me take the pen. So x1 is getting multiplied with wq and you are getting q1. Okay, then x2 is getting multiplied with wq and you are getting q2. Then again x1 is getting multiplied with wk, so you are getting k1, and x2 is getting multiplied with wk, you are getting k2. Then x1 will multiply with wv, you will be getting v1, and x2 will multiply with wv, you will be getting v2. Okay, so that's how you are getting query, keys and value. Okay, these 3 particular vector you will be getting and will be naming as query, keys and values. Okay, I hope you got it. Now let me just clear everything. Now we can see, guys, we are the query, keys and values. Okay, vector. Now here you can see this is the another example. So let's say this is our word. We did the embedding generation, then we got q1, k1 and v1, that means query, keys and values. Okay, and how, I think I already showed you. Now you have to like get this code. Okay, how to get this code? You have to multiply this q1 with k1. Okay, q1 with k1. So if you multiply, you will be getting this particular number. Then again, for the machines, what you have to do, you have to multiply q1 with k2 and you will be getting the number. Now you can see, I mean, which word is having more number? So definitely thinking is having more number here. Okay, 112. So thinking is having more number than the machines. Machine is having 96 and thinking is having 112. Okay, now here will be like generating some, let's say percentage number. For this, some more calculation needs to be done. You can see again the same thing is happening. We are getting the score. Now we have to divide this particular score by 8. Okay, then after that you will be getting the number. Then you have to apply the softmax activation function. I think you know what is softmax activation function. It will give you the probability number. Okay, so in this case we are getting 88% probability of the thinking, and machines we are getting only 12% probability. Now that means your model is giving more attention to the thinking words. Okay, your model is giving more attention to the thinking words. That means thinking words is important, okay, in this particular sentence. Okay, so that's how actually this particular self attention works. It will give you the attention like that. So these are the calculations you will be doing, and it will give the calculation like that. Okay, now I think you are getting. Now one thing, so after doing the softmax, you have to multiply with the value. So this particular value you have to multiply, then we'll be getting the Z1 and Z2. Now I think you understood. So why we are getting the Z1, Z2 here. Okay, so after going through the self attention, Z1, Z2 and so on. Okay, so now I think this particular I think part is clear. Okay, what is Z1, Z2 and so on. Hi guys, in this video we'll try to understand the context window in large language model. So to understand the context window, what I will do, I will open up a large language model from the OpenAI. Just search for like OpenAI models. You will see like the model list OpenAI has. And if you go below, see it will have actually different model, whatever model OpenAI actually published so far. So let's say I will open this model called GPT-4, and I will try to see the context window of this particular model. So what is context window exactly? See, context window is nothing but it refers to the maximum number of tokens, okay, a large language model can process at a one time. That means whatever input you are giving to the model, okay, whatever input you are giving to the model as a prompt, this is called your input token. Okay, this is called your input token. And how many tokens your model can process at a one time, this is called context window. So all the model has one specific context window. Let's say if I'm talking about GPT-4, it has 8192 context window. And what is the maximum output tokens? 8192 maximum output tokens. And what is the knowledge cutoff? December 1, 2023. It has updated with the knowledge base. Okay, that means the information they have trained. So if you go to any model, you will see this particular context window. Okay, now how to count the tokens? So OpenAI has one amazing things called OpenAI Tokenizer. So they use this OpenAI Tokenizer to count the token. So here you can select different model. Let's say I want to select GPT-4 3 and 4, and I want to see the tokens, number of tokens here. So for this, let's say I will copy a text. So maybe I can open up the paper. Let's copy some text here. Now if I pass it here, now it is showing it has 75 tokens and 332 characters. Now you can see this is the tokens, this is another tokens, this is another token, this is another tokens. Okay, this is another tokens. That's how if you count, it has 75 tokens and 332 characters. Okay, I hope you got it. So that's how whenever we pass any kinds of input to the large language model, first of all, with the help of tokenizer, it will count the token and it will match with the this one, your context window. Okay, it will match with the context window. So sometimes if you give like very big prompt, which will, let's say, overcome the context window, that time your model will give the error like input token limit out of range. Okay, these kinds of error it may raise, and that time you will get the error difficult error for sure. Okay, so that's why we also need to take care the input prompt we are giving to the model. It should always less than the context window we have, okay, of the model. So yes guys, that's how we can see all the context window for all kinds of large language model, which it's a Llama, Mistral, Falcon, okay, whatever you have, all the model has the description. In the description they have already mentioned the context window size. Got it? So yes guys, this is all about our context window. Thanks for watching.
So guys, as you can see, what is prompt engineering? Prompt engineering is nothing but prompt engineering is the process of structuring an instruction that can be interpreted and understood by a generative AI model. That means I already told you na, inside generative AI, prompt is everything, and whatever prompt actually you are giving to the generative AI model or your large language model, okay, this should be well structured. Okay, this should be well structured and well organized. Okay, otherwise what will happen? Your model will give random kinds of output. Okay, that is why here I have written the definition what is prompt engineering exactly. Okay, I hope it is clear now. Now as a generative AI engineer, you should have some responsibility whenever you will be working with the large language model, whenever you will be preparing the prompt and all. See, here I have listed down some of the points. Write, refine and optimize prompts, perfect the interaction between humans and AI. That means you always need to make sure whether your prompt is perfect or not. Okay, to communicate between human and AI. That means you will be communicating with your AI assistant. Let's say whatever, let's say application you are having with the help of large language model. Okay, there is a good interaction or not. Okay, the prompt actually you have given, you have to always make sure. Continuously monitor those prompts. You have to continuously monitor those prompts whether this prompt is perfect or not, and is there any change in the model or not. Then maintain and up to date the prompt. That means if let's say model got updated, let's say they again did the fine tune that particular model, and if let's say previous prompt is not working better, in that case what you can do, you can maintain and update that particular prompt for that large language model. So these are the key responsibility you should have as a generative AI engineer. Now let's try to understand why prompt engineering. Okay, so for this I'm going to show you one demo. I think this demo will give you the clear cut idea why prompt engineering is super important if you want to work with the generative AI. So here you can see I have written a prompt. You can see this is the prompt I have written. Correct my paragraph. Today was the great day in the world for me. I went Disneyland with my mom. It could have been better if it wasn't raining. You can see some of the spelling mistake is there. That means grammatical mistakes are there in this paragraph I have written. So what I'll do, I'll give this prompt to my, let's say, large language model. So large language model wise, here I'm going to use ChatGPT. Okay, you can also use Google Bard or any other actually, let's say, model. It's completely fine. But just to show you the demo, actually I'm going to use the ChatGPT platform. Later on, whenever let's say we'll be implementing different let's say application with the help of large language model, that time actually we'll be using this prompt with the help of Python code. Okay, as of now, just to show you the demo, I'm going to use the ChatGPT application. So guys, as you can see, I'm inside my ChatGPT. Now let's say if I give this prompt to my ChatGPT, now let's say if I send it here, see what will happen. See, it has given me straightforward results without, let's say, explaining this like paragraph I have given, without, let's say, asking me any kinds of question. It has given me straightforward answer. So here is my paragraph, and here is the correct of my paragraph, correct version of my paragraph. Today was a great day for me. I went to Disneyland with my mom, and it could have been better if it wasn't raining. Okay, you can see. So here you can see this grammatical mistake I did. It is resolved, okay, by my large language model. Now let's say you are learning about English language, you are learning about grammar, you are learning about, let's say, spelling and everything. Like that means the complete, let's say, English guidance you want, okay, from your mentor. But as a mentor wise, what you want to use the ChatGPT, let's say your large language model. That time, instead of giving this kinds of prompt to the large language model, what you can give, so instead of giving the prompt like that, you can design your own prompt in an effective way. So let me show you another example. So guys, as you can see, this is the next prompt I have designed. So here is the prompt, guys. I want you to act as a spoken English teacher. I will speak to you in English, and you will also reply to me in English to practice my spoken English. I want you to keep your reply neat, limiting the reply to 100 words. I want you to strictly correct my grammar mistakes and typos. I want you to ask me questions in your reply. Now let's start practicing. You could ask me a question first. Remember, I want you to strictly correct my grammar and mistakes, typos and factual errors. Okay, so this is the prompt I have designed. Okay, see, previously the prompt I have given, it was like very straightforward prompt I had given, right? But now what I did, I just designed one very powerful prompt here. Now see, what should be the response from my large language model right now? So let me give this prompt to my large language model. This is the prompt, guys, the same prompt I have given. Now let me send. Now see, it is giving me great. Let's start with a question. What is the most interesting place you have ever visited, and why did you find it so fascinating? Okay, now let me give the answer. Let's say the most interesting place I visited, India, because I loved Indian food. Okay, now you can also do some grammatical mistake. Let's say here I'll just write like that. Okay, now let's say this is my response I have given to my model right now. See, my model will try to correct. First of all, you can see here is the correct version. The most interesting place I have visited in India because I love the Indian food. Now see the reply you have given. So there actually lots of spelling mistakes were there. There are lots of actually grammatical mistakes were there. Now it has corrected everything. Now as a learner, you can easily get to know, okay, so that's how actually you have to write this particular sentence. Okay. Now you don't need any kinds of actual actually English teacher. Okay. With the help of these kinds of large language model, you can easily learn these kinds of syntax. Yes or no? Fine. Now again, it is, you can see, it is asking me one question. Can you tell me more about your favorite Indian dish? That means now this conversation is like more interactive. It's not like straightforward answer it is giving me. It is like more interactive. The way actually human communicate with each other. Yes or no? Now yes, I can give another response. So here I can give I loved chole bhature. Okay. Now let's see the output. So here is the correct version. I love chole bhature. What do you like most about chole bhature? Okay. So here I can write the puri. Now see, this is the correct version. I like the puri. What do you enjoy about the puri? Okay. Now see, this conversation is more interactive. Now you can just keep on replying to the question actually this model is asking. That's actually you'll be learning about the correct, let's say grammar, correct, let's say spelling and all. Yes or no? Now see, with the help of just only one simple prompt design, I got like very interactive output from my large language model. Okay, this is called actually prompt engineering, and that's why it's useful. Okay, that's why it is important, because sometimes whenever you'll be creating any kinds of application, any kinds of LLM powered application, that time you have to design the prompt in such a way so that it can give the correct answer to the audience. Even it can be more interactive to the audience. That means those who are using your application, so they should enjoy your application. Yes or no? So guys, that is why it's like very interesting concept, and it's like very important concept inside generative AI you have to master. Now see, to master the prompt engineering, the first thing you should know about the linguistics. Okay, what is linguistics? Linguistics is nothing but it's a study of language. That means whenever, let's say, you are studying any kinds of language, let's say English language, inside English language you are having some kinds of let's say linguistics. Okay, what kinds of linguistics? You can see phonetics is there. So phonetics means the study of how speech sounds are produced and perceived. Okay, then there is another one called phonology, the study of sounds pattern and changes. That means whenever we are speaking any kinds of, let's say, language, like how this sounds look like. Okay, how these sounds look like, how you are pronouncing this particular word and all, this is called actually phonetics and phonology. Got it? Then there is another one called morphology, the study of word structure. Then there is another one called syntax, that means the study of the sentence structure. That means whatever grammar you usually learn inside English. Then you have also having the semantics, that means the study of the linguistic meaning. Then the next one is pragmatics, the study of how language is used in the context. Then historical, the study of language change, then so on. Okay, you can see these are the actually linguistics are available to study about the language. Okay, and if you have good knowledge, on these kinds of, let's say, linguistics, definitely you can design a very good prompt for the large language model. So that's why I have written here, linguistics are the key to the prompt engineering. That means if you are having good knowledge about linguistic, definitely you can design a good prompt for the large language model. Now we have already studied about like large language model or our generative AI model, right? So there are different kinds of generative AI models are available, like GPT, BART, then Lambda, Palm, Bloom, Llama, Cloudy. Okay, then Nemo LLM. Okay, Generate. So these are the actually, apart from that, like there are so many large language models are available. I think I showed you one GitHub, right? I think remember Open LLM GitHub. There I think you saw thousands of large language models were there. And these are the provider and vendor. Okay, like those who are created this, these are the actual large language model. See, all kinds of large language model over the internet, all the large language model accept this prompt. Okay, that means you have to give the prompt there if you want to use this kinds of large language model. Okay, because this large language model is already trained with huge amount of data, huge amount of unstructured data. Even they also did something called supervised fine tuning. They also applied something called reinforcement learning technique to improve the quality of the model. That means this model is also trained with the instruction, lots of instruction. That means they did the chat operation with this model. I think I showed you one in one video, one of my video, I already explained how ChatGPT were trained. Okay, so that's why whenever they trained with this kinds of instruction data, that means they are passing the prompt. And whenever you want to use this particular model, you also need to provide the prompt. I think now it is clear why this prompt engineering is super important. And whenever you want to use any kinds of large language model, why you have to use the prompt engineering technique. That means why you have to give the correct prompt always to the large language model. Now let's learn about some best practices to design a prompt. See, if you want to design some best prompt for the large language model, you have to keep some of the point in your mind. Let's say the first thing, clear instruction. Definitely you have to give the clear instruction to the large language model. Then adopt a persona, then specify the format, avoid leading the answer, and limit the scope. Okay, so these are the things actually you have to always remember. Now let's open our chat GPT and let's try to see some of the best practices, okay, we can perform whenever we're giving any kinds of prompt to the large language model. So guys, let's say if I give a prompt here, let's say I'll give when is the election. Okay, when is the election? Let's say this is my prompt. Okay, now see, if I pass this prompt to my large language model, let's see the output. It depends on which election you are referring. See, election can be vary by the country, definitely, because it's the correct one. Now you are asking what is the election, but you are not clarifying. Okay, you are not clarifying in which country you are referring. Okay, that means you have to always pass a clear prompt, okay, clear instruction to the large language model. Now see, I can give this prompt like that: when is the next president election in USA. Okay, now see, this prompt is clear and it is like well organized for my large language model. Now see, if I pass, now see, this is the answer. The next US president election is scheduled for the November 5th 2024. Okay, now I'm getting the correct answer from my large language model. But whenever you are not giving any kinds of clear, let's say clear let's instruction to the model, it will give you unnecessary output. And again, it's a chargeable, because whenever you are using ChatGPT or let's say any kinds of let's say commercial large language model, it is charging based on the token, input and output token. I already showed you, okay, how it will count the token and how it will charge. So whenever you are getting these kinds of unnecessary output, that means unnecessary you are spending your money, yes or no? Okay, so that's why whenever you are using these kinds of commercial large language model, make sure you have the proper prompt, so that in just one prompt you will get the actual output you are looking for. Okay, this is what actually you have to always remember. Now let me give you another example. I'll just write a code to filter out the ages from data. So let's say this is my prompt I've given. Now see, my LLM model has given me this is the output. But let's say you are looking for Java code. You are looking for Java code, but it has given you the Python code. Again, what you have given? You have given actually uncleared instruction to the model, yes or no, right? So you have to give the clear instruction always. Now you can write this prompt like that. Write a Java code, okay, to filter out edges from the data. Now see, now it is the clear instruction to my large language model. Now I will get the Java code. Now let's see the next one, like the adopt the persona. Okay, like what is the persona exactly? Whenever you are giving any kinds of let's instruction to the model, what kinds of persona you have to adapt there. Let's say this is one prompt I'm giving to my large language model. Write a poem for a sister's high school graduation that will be read out to the to family and close friends. Okay, let's say this is my instruction I have given to my large language model. Now see, here is the response I will get. So here is the response I got. That means this is my poem. Now if you read this poem, actually this is not actually much interesting, the poem actually I was looking for. Now what you can do, you can actually give the persona. Okay, you can give the persona whenever you are giving the prompt. So now let me show you another prompt I have designed for this. So this is the prompt, guys. Now here I am writing, write a poem as Helena. Helena is a 25 years old and amazing writer. Her writing style similar to the famous 21st century poet Rupi Kaur. So I think you know about Rupi Kaur. You can also search about Rupi Kaur. See, she is actually a Canadian poet and illustrator. Okay, you can read about her. Now see, writing as a Helena, write a poem for her 18 years old sister to celebrate her sister's high school graduation. This will be read out to the friends and family at the gathering. Okay, now see, this is the prompt actually I've given. Now see, if I send it, if I send this prompt right now, now see the response actually I got here. Now if you read this poem, actually it is too good. It is too good than my previous response I got. Okay, so that's how actually you have to adapt the persona always. You have to adapt the persona what kinds of things you are looking for. Now see, this large language model is already know about rupee core, okay, because it is already trained, let's say around 2022 data, okay, till 2022 data it has already trained, and in that data actually rupee core poem was there, okay. That's why that's why this model is already known about rupee core, and it is trying to get the similar kinds of, let's say, poetry, okay, whatever, let's say, poem actually rupee core used to write, okay, the same actually syntax context actually it is trying to, let's say, gain. Now the next thing, you can also specify the format, let's say what kinds of format you want as a output. Let's say what I will give you one example for the summarization. Let's copy one English story here. So let's say this is one English story. I'll just try to copy the entire story, and here I'll go to my chat GPT and I'll just write please summarize this story, okay, summarize this story. Now I can pass the entire story here. Now see, I can send it. Now see, it is giving me the summary, but see, this summary again, it's a paragraph, okay, it's a paragraph. Now I can also specify the format. Let's say I'll give I want, I think I can copy the same instruction. Now here, just try to modify. Please summarize this story in bullet point, okay, bullet point. Now see, I'm specifying the format. Now see, if I pass this, now see, it will give me inside a bullet point, okay. Now see, it's like more readable, nah? It's more readable. It is giving me some actually important actually summary of this entire story. It is trying to return me, okay. So that's how you can provide any kinds of format you need. Let's say you need a data and you need a JSON format data. You can also provide, I need a JSON format data, okay. You can pass the prompt and it will give you that. So that's how actually whenever you are designing your prompt, you have to always keep these are the point in your mind, okay. The point actually I listed down in my presentation. I think you saw that, right? Now there are some types of prompt are available. So the first type you can consider zero shot prompting, and the second type actually few shot prompting. Apart from that, actually there are like some types of prompts are available like emotional prompting and all, right? But this is not actually required. But if you want to create any large language powered application, so this two prompt actually very famous. So I have seen like people are using this to prompt a lot, like few shot prompting and zero shot prompting. So let's explore this zero shot and few shot prompting in the example. So again, I will go to my chat GPT. Now, first of all, let's write the zero shot prompting. Zero shot prompting means you are only asking the instruction, because see, this chat GPT is already trained with huge amount of data. So this chat GPT has already like lots of knowledge about, let's say, the data over the whatever data they have trained. Now let's say I will ask one question: when is the Christmas in America? Now see, Christmas in United States celebrated on December 25th each year, okay. Now it is giving me the answer. So this is called actually zero shot prompting. That means you have only give one prompt, okay, one prompt. That means the instruction you have given, the question you have given, okay. But let's say if I ask these kinds of question, now let's say if I ask this kinds of question, what is Bappy's favorite types of food, okay. Let's say this is the question I have given. Now say it will give you, I don't have the information about Bappy favorite types of food. Could you please provide more details, clarify who is Bappy, okay. Now see, here actually zero shot prompting is not working. So here you have to pass the few shot prompting that time, okay. Now see, here I'll give a prompt. Now I'll just write Bappy is a data scientist and his favorite types of food are, or you can write food includes, let's say, burgers, pizza, okay, and chicken. Now I can pass this prompt to my large language model. Now it will learn about me, okay, because I have given a few short prompt here, okay. Now see, got it. Bappy favorite types of foods are burger, pizza, chicken. And if you need any more details or have a questions, just let me know. Now here I can give another prompt. What is the, or I can write what restaurant. Now let's say this is the prompt I have given. What restaurant should I take Bappy to in Dubai this weekend. Okay, now see if I pass. Now see, it will suggest me some restaurant. Dubai has fantastic range of restaurant that caters a variety of tastes since Bappi like burgers, pizza and chicken. Here is the few recommendations. So here is the restaurant. Now see, this is called actually few shot prompting. That means you are also giving some few shot prompt. That means some let's say information about the question you are asking. Okay, this is called actually few shot prompting. So these are the thing guys you have to master. So see, this prompt engineering will come automatically whenever you will be writing this kinds of prompt. So unless and until you are not writing, you are not experimenting, you won't be able to understand okay which prompt will give you what kinds of output. So try to practice a lot. Okay, you have the chat GPT, you can give different prompts and you can get the response from the chat GPT. And the prompt actually you are giving to the chat GPT, the same prompt you can use to any kinds of large language model. Okay, in future you will be using, whether it's a let's say Gemini, whether it's a let's say Mistral, Falcon, whatever let's say your model you are using, you can use it as it is. Fine. Now there is another concept inside actually generative AI model called AI hallucination. Now what is an AI hallucination? See, AI hallucination is when a large language model generates false information. That means let's say you are giving a prompt and that model is giving you the false information. Okay, so this is called actually AI hallucination. That means the prompt you are asking, the information you are asking, this information is not available to the large language model. Okay, so that time what we have to do if we are getting this kinds of hallucination, so that time we can use something called RAG concept. That means Retrieval-Augmented Generation. That means we can connect our external data source to my large language model. Okay, and from that data sources my model can learn okay this is the information you are looking for. And if RAG is not working, that time what we can perform, we can perform something called fine tuning of a large language model. I think I showed you. Now we can perform fine tuning with the help of Hugging Face. Okay, so I'll also show you how we can fine tune different kinds of large language model on top of our custom data. We can also perform fine tune operation, but fine tune is a costly task because here you need a good system, like lots of data. Okay, so again it's like very costly task, but RAG application is a very easy kinds of task. See, here you don't need lots of cost, here you don't need lots of computational power. Okay, so both will be exploring one by one, like what is RAG concept and what is let's say fine tuning concept, everything will be exploring. Okay, so yes guys, this is all about our prompt engineering. Now I think you got it why prompt engineering is super important and how you can master this kinds of prompt engineering technique. Okay, it's nothing but it's just a way of let's say communicating with your large language model. The input you are giving to the large language model, this is called actually prompt. Okay, and the way you are designing this particular prompt, this is called prompt engineering. Okay, I hope it is clear now.
Hi guys, in this video we'll try to understand user prompt and system prompt inside LLM. So for this what I'm going to do, I'm going to open up a platform called Grok Playground. Okay, so Grok is a platform guys, so here you will be also getting large language model. So here you can create an account and Grok will also give you the API key. With the help of API key you can access different model. Okay, so this is the interface of the Grok. So here you can see different models are available. Okay, so you can see all kinds of models are available. Okay, you can access these other model through the API request. So as of now I'll just try to show you what is the user prompt and what is the system prompt. Okay, because nowadays whatever large language model you use, we use something called chat completion model. Okay, all the models are chat completion, and these are the model takes two kinds of prompt. One is the system prompt, another is the user prompt. You can see, so here I have selected one model called Meta Llama. Okay, Llama for this particular Llama for Scout model I have selected. Now you can see whenever I selected this model, so it is asking me two kinds of prompt. One is the system prompt, another is the user prompt. So what is the system prompt? So here you can pass the system prompt if you want to perform some specific task. Okay, by using your model. So let's say here I will give URN. Okay, URN, or let's say URA translate expert. Okay, experts. Now here you can give the user prompt. That means whatever user will give. Let's say I will just write translate this sentence to Hindi. So let's say here I will give a sentence. My name is Bappi. Okay, so this is the sentence I have given. Now if I submit it, so you'll see that I will get the translated output. So you can see this is the translated output I got. So here, what we are doing actually, we are specifying the task, because this kinds of LLM model uh, actually can work with, because this kinds of model has various kinds of tasks. Okay, because these model call actually multitasking model. You can perform language translation, you can perform text summarization, you can perform content generation, code generation, everything you can perform. So it's better whenever you are creating any kinds of specific application. Let's say I want to only create the language translation, so that time you just try to provide the system prompt. Okay, so that your model will more focus on the translation part. Okay, whatever user is giving, that will give you the translation. And in the user, okay, we'll try to give the prompt, that means our input prompt. That means system prompt you have to mention one time, and user prompt, okay, it would be let's say changing multiple time. That means whenever user will give any kinds of input, you have to pass to the user, and to specify the model to a specific task, you have to use the system prompt. This is the idea. And you can also play with the temperature and max token parameter if you want. Okay, so yes guys, this is what actually our system prompt and the user prompt. I hope you got it. Because nowadays whatever model you will be using, all the model has the same things. Okay, system prompt and the user prompt. We call it as a chat competition model. Okay, so yes guys, this is all. Thanks for watching. Hi guys. In this video, we'll be talking about open source LLMs and proprietary LLMs. Okay, what is the difference between them? So here you can see open source LLMs is nothing but, so just let me show you. So open source LLM is nothing but the models are publicly released, okay, with access to the weights, codes, and training detail, enabling users to inspect, modify, and fine tune and deploy locally or any other infrastructure. That means if there is any model which is publicly available, that means the weights, codes, okay, and everything, all the model details, that time you can call it as an open source model. So I think you know that some popular open source model are available like Llama 2, 3, Mistral, Falcon, Bloom, okay, Phi, then Queen, okay, and so on. So these are the models are open source. And you can see the creator, so who has created the model, even you can see the context length of the model. And what is the pros and cons of this model? So you can see the pros part. So this model are transparent, architecture and weights, so customizable, you can fine tune and quantize whatever you want, you can do. Then you can run on locally, okay, no vendors locked in, and great for research and innovation. Let's say if you are interested in research and innovation, you can use this as the model. And what are the cons are available? So it requires actually infrastructure and engineering expertise, okay, then often smaller scale or less optimized than the proprietary, okay, LLMs. That means here you have to use actually larger scale infrastructure to run this model, and security and performance tuning is your responsibility. So here you have to take care of your security and performance tuning. Okay, these are the part. Then there is another one called proprietary LLMs. Okay, so you can see closed source models developed by companies where only the API or hosted access is provided. The models weight, training data, and the internet's internals, okay, are not publics. That means only you have the API. Through the API request you can access the model. I think you know that GPT model, that means OpenAI, whatever model they are having, so those are model actually proprietary LLMs, okay, because you can only access those models with the help of API request. Then Cloudy, Gemini, okay, Command, then Jurassic. So these are the companies you can see provider, and this is the context length. And what is the pros and cons? You can see state of the art performance, scalable, reliable APIs, fully managed infrastructure, accessible to a massive context window. Then idea, well, for the enterprise use cases, okay, and speed to deploy. And what are the cons? So no access to the weights and or the data, expensive because at the end you have to pay, risk of the vendor locked in, limited customization, okay, and potential privacy compliance concerns, data leaves your infrastructure. Okay, so these are the pros and cons are available if you're using this proprietary LLMs. So yes guys, in the market these two kinds of large language models are available. So whenever we'll be creating any kinds of production ready software, most of the time we'll be using proprietary LLMs, because you can see the pros and cons. Okay, so it is more easy to let's say manage and let's say scalable, to make it scalable. And whenever I'm talking about open source, here you have to take care of everything. Okay, so at the end it's like more costly, because at the end you have to take the good infrastructure, you have to deploy the project, you have to, so you have to take care of everything here. But let's say if you're doing research or any other innovation, that time you can go with open source large language model. Okay, it's up to you. So yes guys, this is the difference between our open source and proprietary LLMs. Now I think you got it. Thanks for watching. Hi guys, in this video we'll see some comparison between some large language model. So you can see I have listed down some name. So Llama is there, GPT is there, Cloud is there, Mistral is there, and Gemini is there. Okay, so you can see some comparison. So the latest version of Y is Llama is having I think Llama recently updated one more version, Llama 4. So you can consider Llama 4. Then GPT 4 is there, Cloudy is there, Mistral you can see, okay, and the Gemini 1.5 Pro Flash. Then the model type you can see, it's a decoder only transformer model. It is also decoder only transformer model. And the cloud you can see, it's a constitutional AI plus transformer. They are using the architecture. The Mistral MOE mixer of experts, okay, and dense, okay, dense layer they are connected with. And the Gemini multimodal transformer, text, image, audio, and code. Open source wise, yes, Llama is open source. This GPT is not open source. Cloud is also not open source. Mistral is open source. Gemini is also not open source. Okay. Then size, you can see this is the size of the model. You can see sizes available. It is having 8 billion, 70 billion, GPT 3.54, then small and large, then 7 billion and 12.9 billion and not disclosed. Okay. Then context window wise, it is having 8K to 2K actually context limit, then 4K to 128K, then 200K. Okay, then this is the context set, and up to 1 million tokens. Okay, then fine tuning wise supported. If you want to, there's a fine tune with the help of parameter efficient fine tuning like LoRa, you can do it. Proprietary fine tuning only, that means you can only fine tune in their platform only. Not yet, you can't fine tune the Cloudy. Then yeah, you can also do it. And Gemini you can also do. Then tooling wise, Hugging Face platform you can use to access the model, and you can use OpenAI API to access this model. Cloudy API you have to use. This model is also available over the Hugging Face transformer. Gemini API, okay, you have to use. Then local inference wise, yes, you can do the local inference of Llama. GPT you can't do. Cloudy you also can't do. Mistral you can do, and Gemini you can't do that. Then multi-model, it is a text only model. This is actually vision supports. Then it is also having multi-model. This is also only text only model, and image, audio, code, text model. Okay, that means multi-model. Then unique strength, you can see best OS for the fine tuning, industry leading performance tools, best long reasoning. Okay, then you can see first OS MOE models and unmasked context plus multi-modality. Then pricing wise, it is free, it is paid, again it is paid, it is free, again it is paid. Okay, so these are some comparison between some large language model. There are so many large language models are available over the internet. So let me show you one website. So if you go to Google and search for Open LLM, okay, Open LLM GitHub. So there is one amazing GitHub actually you will be getting. So this person has collected all the large language model, okay, and he has created one GitHub repo named Open LLM, and he has also listed down. You can see the model name, release date, checkpoints, paper and blogs. If you want to understand this particular let's say model, you can refer the blog. When the parameter size, context length, and the license. See, all kinds of large language models are available. Okay, so you can check it out guys, because it's not possible to remember all the model name. You just keep this particular GitHub with you, just try to bookmark, and whenever you require anything, just try to come here and try to see the paper and blogs. Okay, and just try to use the model. So yes guys, this is all about from this video. I hope you liked it. Thank you so much. Hello everyone, we'll try to see what is pre-training, fine-tuning, and instruction training. So you can see in the pre-training here, the main objective is to learn the general knowledge. That means you just try to train the model with massive amount of unstructured data, and it learns the pattern, it's learned the grammatical, let's say, concept and all. Then in the fine-tuning, you just try to train the model to a specific use case. Let's say you want to do only language translation, or let's say text summarization, you will be working on that. And in the instruction training, you just try to follow the human instruction technique. Like you give some instruction. Let's say I want to do language translation. First of all, I'll just write translate this text, okay, to a specific language. Then I will give, let's say, the specific language English. Then I want to translate to French. Okay, so I will also give the same example. That means here I'm giving the complete instruction, and my model will get trained. Okay, on top of that, then you can see data wise, here we'll use unlabeled massive data, and here we use domain specific data, and here we use instruction response paired data. Okay, so here supervision wise, actually you can see it's self supervised technique we use, and here we use supervised and unsupervised technique both. And in the instruction technique, we use the supervised technique, because here we are also giving the label data, we are also giving the instruction to the model. Okay, that's why. Then customizable wise, not specific, task domain specific customization you can do. And here you can consider dialog following instruction. That means if you want to customize, you can give the dialog on the or any kinds of let's say instruction, okay, to the model. Then output behavior wise, actually it's a generic, knowledge rich and narrow specified, okay, and this one narrow specialized, okay, and this is one the conversational task aware actually technique, and this one follows actually conversational task aware technique, okay. So yes, these are the like difference between your pre-training, fine-tuning, and instruction training, okay, process. So most of the time people usually do the fine-tuning process if they want to train with any custom data, specific data. And nowadays we have some better option like RAG is there. With the help of RAG is RAG, what we can do, we can connect with our custom data, okay. I will also show you this part, what is RAG exactly and how it works, and how we can build a RAG application, okay. We'll also try to cover that. So yes guys, this is all about it. Thanks for watching.
So guys, I think you already know inside generative AI we use something called large language model, that means LLMs. So LLMs actually have some limitation. You can see the first limitation it is having. So the first limitation you can see, LLM can't answer correctly to the private data. Let's see if we're having any kinds of private data, so that large language model won't be able to give you the answer related that. So if I give you one example, let's say you are having one personal website. Let's say I have one website called Code Commander. Okay, so Code Commander is my website. Now if you open up your ChatGPT and if you ask related Code Commander, your ChatGPT won't be able to give the answer because ChatGPT trained with older data. That means I think ChatGPT trained around 2021 to 2022 data. Okay, around this year actually they trained this model. After that actually I created this channel. Okay, so this data is not available inside my ChatGPT knowledge base. That means that time actually this data was not available in the internet. Okay, so you can consider it's a private data, or you can consider any kinds of private data, your private let's say website data, private let's say your company data, anything. So if you ask any question related to the private data, your model won't be giving you any kinds of response to that, right? Then you can see the second limitation, LLM can't provide the most current information. Let's say if you're asking any question which is like more current, okay, more current let's say information, your model won't be giving you the answer. Let's say if you ask the question related this Olympic, okay, the current Olympic, it won't be able to give the answer because it hasn't trained with the current information. Okay, so these are the actually limitation we're having with the LLMs. But I want to create an application. That application will be also able to give the answer related to the private data as well as the current information. So how it can be performed? Okay, we can do it with the help of RAG concept, that means Retrieval-Augmented Generation. Now let's see how RAG works. So guys, here you can see RAG allows LLMs to use external sources for the better response. That means let's say if you're having any private data, let's say any external documents. So what you can do, you can give that documents to the large language model. How? For this, you just need to use one embedding model. You just need to use one embedding model. With the help of this embedding model, you'll just try to generate the vector embedding of the data. The data actually will be giving. And this vector embedding you will be storing to the knowledge base. That means to the vector database. Okay, I think we have already learned this thing previously. Previously, we already implemented this kinds of application. But I think you didn't know. Okay, this is a RAG application. I just given some high level overview, like how we can, let's say, use our external documents. I think we already created some of the project, right? So yes, this is called actually RAG. That means we are using our external documents. We are creating our knowledge base. And to the knowledge base, actually, we are integrating our large language model. Okay. Now, whenever user is asking any kinds of question, okay, whenever user is asking any kind of question to the private data, what it will do, it will go to the knowledge base. Okay, it will go to the knowledge base. Knowledge base will give the response. Okay, the question you are asking, the relevant question you are asking, and your LLM will process that answer as well as the query, and it will give you the correct response. Okay, so this is the complete architecture of RAG. That means Retrieval-Augmented Generation. Okay, so with the help of this concept, actually, we can easily use our private data sources or let's say external documents to get the information. Okay, I hope it is clear. That means if you are using RAG concept, it would be more accurate answer on the private data. Stay updated with the new information. Let's say if you're having new information, new data, what you can do, again, you can give that data to the knowledge base. That means you can use embedding model. You can convert those data to the embedding representation. You can store to the knowledge base and you can connect your large language model there. And if you're asking any question related that information, it will give you the answer. Okay, your model will give you the answer. So this is the concept of Retrieval-Augmented Generation or RAG. So guys, now let's try to see how RAG works. So as I already told you, whenever you are using RAG, that means you are connecting your external data. That means your private data. Let's say you have connected your private data. Let's say you have connected your website. Okay, you have connected your website. That means from the website itself, it will extract all the information. Let's say you are running one e-commerce site. So user has asked one question, what are your business hours? Okay. Now how it will give the response by using your information. So first of all, what it will do, it will try to use something called retriever. So with the help of retriever, it will try to fetch all the information from your website. Okay. All the information it will fetch from the website itself. Then it will perform something called augmentation. So what augmentation will do, it will just try to augment the query. That means whatever question user has asked, okay, and the data actually you are getting after retriever, so it would be actually augmented. That means it will add them together. Okay, let's say the query as well as the data. Then it will pass to the generation. That means to the large language model. Large language model will try to understand the entire data as well as the query user has asked. Okay, and based on that, actually it will provide the answer. So the answer is Monday to Friday from 9:30 a.m. to 6:30 p.m. Okay, so that's how actually RAG works. That means it will use actually three components. One is like retrieval, another is like augmentation, another is like generation. Okay, that is why it is called Retrieval-Augmented Generation. Okay, I hope it is clear now. So guys, this was the introduction of the RAG, and I think you got it, how RAG works and all, and why RAG is important. Now let's try to see one practical example of RAG. So guys, here you can see I already prepared one code example of the RAG demo. So first of all, we'll try to understand this Jupyter notebook file. Then I will also show you how we can create a user application. That means app, let's say Streamlit app, how we can create it. Okay. So for this, what you have to do, guys, first of all, you have to install. These are the requirements, and this code would be shared, guys, in the resources section. From there, you can download. And I already told you how to create a virtual environment. So to create the virtual environment, you have to execute this command. So conda create -n. You have to give the name. Let's say here I have given openai demo. You can give any kinds of name. Let's say I will give test, then Python is equal to 3.10. Okay, 3.10, then -y. So this is the command you have to execute, and make sure you are using Python 3.10. Okay, so for me, I already created. I'm not going to create again. Then after that, you have to activate it. That means conda activate your environment name. Okay, then you have to install this requirements. Just write pip install. Okay, -r requirement.txt. Fine. Now if I see press enter, it will install all the requirements I'm having in the requirements of file. You can see inside requirements file, I'm installing LangChain community, LangChain openai, python.emb, Streamlit. Okay, so these are the actually dependency package you have to install one by one. So for me, I already installed each and everything, you can see. Then after that, just open this notebook, RAG demo notebook, and try to select the environment. So let's say I have created this environment, openai demo, I'll select it. Now see, now if I execute the first line, see, it is working fine. There is no error. Okay, that means it is working fine. So guys, in this experiment, I'm going to use one website. Okay, that means as a private data, as a, let's say, external data, we'll be using website. So from the website itself, we'll be collecting the data. On top of that, actually, we'll be implementing this RAG application. So you can see this is the website URL. Now let me open this URL. So this is the URL of the website. So this is the entire website, guys. You can see. So they have given different information. So now I just collected some of the more page. Let me show you. So this is another page. This is the index page, and this is the contact page. Okay, now let me open them. See, this is the index page, this is the contact page. So you can see, guys, this is the index one and this is the contact one. Okay, so that's how actually you can use any kinds of website. I'm using this website. For you, you can use your, let's say, personal website. You can use your, let's say, private website, your official website, anything you can use. Even I will also show you how we can use any other format. Let's say how we can use PDF documents. Okay, these are the things I will also tell you. So this is the website data actually I'll be using. Now to load this website, I'll be using something called unstructured URL loader, and this is available inside LangChain. Okay, you can see I'm importing this unstructured URL loader. Now this is the URL list. So if you're having multiple URL, you can create a list, and this list you can pass to this function, and this function will give you one loader object. Now you can call loader.load, and it will extract the data. Let me show you. So if I execute this line, now see, it is extracting all the information from the website itself. So extraction is done. Now if I show you the data, now you can see it has extracted all the information. Now why 3 documents is coming? Because here I was using 3 URL. Okay, 3 different actually pages. Okay, that's why it is coming 3 documents. Okay, now what I have to do, guys, I think you remember we have to perform something called chunking operation. So for this we can use recursive character text splitter. Either we can use character text splitter, either you can also use token text splitter. Okay, so here I'm using recursive character text splitter. So here chunk size is equal to, I have given 1000. That means 1000 word would be considered as my 1 chunks. So let me create the chunks and let me show you the chunk size. Okay, you can see 11 chunks it has created. Okay, now if you want to see the first one, so you can see this is the first chunks, and this is the URL it is referring. Now I think you remember, after extracting your data, that means documents, you have to use one embedding model, and you have to generate vector embedding, and that vector embedding will be stored into the vector database. Okay, any kinds of vector database you can use. So I have already showed you like multiple vector database. Like we can use ChromaDB, Pinecone, Web8, okay, Files. You can use any of the vector database. So here I'm going to use something called ChromaDB vector database. Okay, ChromaDB is a local vector database. Fine. So guys, you can see I'm importing Chroma from the LangChain itself, because inside LangChain this ChromaDB is available. Then I'm importing one embedding model. So here I'm using OpenAI embedding model. Okay, OpenAI embedding model. You can also use any open source embedding model. I'll also tell you okay how we can do it. Then I'm also importing OpenAI. That means I'm going to use OpenAI large language model. So let me import all of the package. And now if I want to use OpenAI, what I have to do, I have to set my environment. Okay, environment variable. So OpenAI API key, you have to pass your API key. So just try to create one API key and try to pass here. Then let's load this API key with the help of load env package. Then after that, I'm going to initialize my ChromaDB vector database. Okay, so you can see I'm going to pass my documents here, the documents I'm getting. Even I'm also passing my embedding model. So it will give me the vector store, entire vector store. That means this is going to be my knowledge base. Okay, see, this is my knowledge base right now. Now here you can perform something called semantic search operation. Okay, similarity search operation. So let me show you one example. So vector store as retriever. I want to perform similarity search operation. Search keywords, that means how many, let's say, result it will return. So here I've given 3. That means after searching, it will give me 3 relevant answer. Okay, let me show you. So let me create the retriever object. Now here I'm asking one question, what kinds of service they provide. Okay, this website, let's say I'm asking one question. Now if I perform the invoke operation, see, it will give you 3 results. Okay, 3 results actually it will give you. So let me show you. See, it has given you 3 relevant information, and from where it is referring, it has also given the URL, and you can see the 3 relevant information. But what I need the actual response. Okay, this question I have asked what kinds of service they provide. I need the actual response. I don't need this kinds of response. Okay, for this what I have to do, I have to connect my large language model. I think you remember. So here I have to connect my large language model. Okay, then user will ask the query. So it will process the query as well as the relevant, let's say, answer will be getting from the vector database. Then your LLM will give the actual response. Okay, so now let's try to see how we can perform it. Now, if you want to see the page content, okay, the let's say result you are getting, if you want to see the contents, what you can do, you can call this one page content. Okay, I want to see the first, let's say, answer page content. So this is the entire page content. You can see. Fine. Now here I'm initializing my large language model. I think you know what is temperature parameter, what is max token parameter. Now here you can see I have created one chain. Okay, create retrieval chain. So this will give me the chain object. That means I can connect my large language model as well as the vector database. Okay, then I'm also going to pass one prompt. Okay, system prompt, and for this I'm going to use prompt template. Okay, I think you remember we can also create the prompt template. So this is the prompt I have created, guys. You can see you are an assistant for the question answering task. Use the following piece of retrieved context to answer the question. If you don't know the answer, say that you don't know, use 3 sentence maximum to keep the answer concise. You can also change the prompt, it's up to you, but I will use this prompt. Okay, it will take the context and it will give you the answer. Now for this I'm going to create a prompt template first of all. So here I've created the prompt template. This is going to be my system prompt, and user will give the input. Okay, whatever input actually user will ask, let's say this is the input user will ask. Okay, this input actually it will come here. Okay, and it will create the complete prompt that time. Now let me initialize the prompt. Now here I'm going to create a chain. So I'm using create stop document chain. So this is the function actually I'm using, because I already told you inside LangChain actually we are having different chains, right? Now here I'm passing my LLM as well as the prompt. Then again, what you have to do, you have to call another function create retrieval chain. Okay, so inside that you have to give your vector database. Okay, the vector database you have created, that means your knowledge base, and you have to give this object, your question answer chain. Okay, this object actually you have to give. Now it will give you the entire RAG chain. Now here you can ask any kinds of questions. So here I am calling this RAG chain invoke, and this is the input, what kinds of service they provide, and I'm only extracting the answer. Now see, if I show you the answer right now, see, this should be the concise answer. That means the accurate answer actually it will try to provide. Now see, Victoria on Move provides efficient and careful relocation services for the apartment, village, householders. Okay, see, blah blah blah. That means it is giving me the correct information right now. Okay, so this is called actually RAG system. Now it is referring my private data, my external data. On top of that, actually it is giving me the answer. And if you ask this question to the ChatGPT won't be able to give the answer, because ChatGPT hasn't trained with this data. Okay, I think you are getting my point. Now let's try to see how we can create a user app. Okay, so what I've done, I've created another file called app.py, and whatever code I have written, okay, cell by cell, I just copy pasted and I just created like that. In this particular dot file, you can see I've imported all the library. I'm loading my, let's say, secret keys, that means OpenAI API keys. Then I'm giving the URL, I'm extracting the data, I'm creating that means chunks. Okay, then I'm creating the vector store. I'm initializing my large language model. then I'm using Streamlit. You can see st, then I'm initializing my prompt. So you can see this is the prompt. And now if user is asking any query, this query actually I'm passing here and it is giving me the response. That response actually I'm showing on the Streamlit application. Okay, now let me execute and let me show you how this app will look like. So for this, you can execute one command called Streamlit run app.py. Okay, now see if I execute the command, so it will open up my application. Now see, this is the title. I think you saw that st.title we have written here. See, RAG demo. And this title will show in the search bar. You can see this is the search bar because here I'm taking chat input na. So you can see this is the chat input. Here it will show the message. Now you can change the message as per your requirement. Now let me ask one query. So I'll ask the same query. So I'll copy this query. And here I can ask. You can go to the website and you can ask any kinds of query. It's up to you. So guys, as you can see, it has given me the response. Victoria Move provides range of services including apartment moving, villa moving, okay, and so on. That means it is working fine right now. You can ask any kinds of question, guys. Any kinds of question you can ask, whatever actually information you are having in this website. Fine. So yes, guys, this is the RAG demo, and that's how we can create a RAG. So thanks for watching, guys, and I will see you next time.